at this last topic that we've got here. We are looking at connected rates of change, and this type of question is a little bit different to maybe some of the previous ones that we've had a look at. When I'm reading through this question, I want to see if you can work out what might be different about this question. So it says the volume of a hemisphere, v centimeters cubed, is related to its radius, r centimeters, by the formula v equals 2 over 3 pi r cubed, and the total surface area S is 3 pi r squared. Given that the rate of increase of volume in, this should actually say in centimeters cubed per second, dv dt is 6, find the rate of increase of the surface area ds dt when r equals 9. So you may find this difficult to spot, but there's something about this question that's a little bit different. Does anyone think they might be able to spot what could be different about this question? I'll give you a little bit of time to just think about this to see what potentially could be different, and then we'll see if we can discover it together if we can't see it yet. Anyone got any ideas of anything they think that could be different about this? Sarah?
Is it the fact that we don't have an equation to do with like the differential equation?
Yeah, that's really, really well spotted. We don't have anything that we're trying to do which is with r. So the things that we've got ds dt, which is the thing we're looking for. We've been given dv dt, and it doesn't look like we've got something that's with r, and we're going to sort of explore that a little bit more. I think it might become a bit more obvious of what's actually going to be happening here. So let's just break this question down a little bit further. We've got a hemisphere meaning half a sphere, yep. And so the volume of a hemisphere is 2 over 3 pi r cubed. That's definitely going to be an important fact. So I'm going to write that it's 2 over 3 pi r cubed. Obviously now then we know the volume for the formula of a sphere. Sorry, the formula for the volume of a sphere is 4 over 3 pi r cubed. And we've then also been told that the surface area is 3 pi r squared. Anyone think they can work out what the surface area of a sphere is if a surface area of a hemisphere is 3 pi r squared? That's the instinct to think it would be 6 pi r squared, but it's not 6 pi r squared. Why is it not 6 pi r squared? Why can't we just double it? Good, because if you doubled the surface area, you'd actually have the flat bit in the middle of it as well. So if you take away the flat bit, what would the flat bit leave you with if you remove the flat bit? So you've got 3 pi r squared, take away pi r squared from that to get the cover of the top half of a sphere. So it's 2 pi r squared. So the whole sphere is 4 pi r squared. So it's like the 6 pi r squared, but you have to remove the central disk twice. Okay, just nothing to do with this question, but just interesting to see what some of these formula might be as well. They've rather generously told us that this is dv dt, but how do I know that it's dv dt even if they didn't tell us that? Good, because it's the rate, which means dt, and it's to do with the volume, and we've got the dv. And we also should notice that volume is centimeters cubed and dt is per second. And again, we've got rate, which means dt, and we've got the surface area, which is the ds part that we've got there. So we are aiming to try and find out what am I looking for? I want to try and find out what ds dt is. We've already been told some other facts. We've been told that dv dt is equal to 6, and we've been told we're trying to find it when the radius is equal to 9. Before I even dive in and try and work out what this thing is here, what do we usually do with these two formulae? Differentiate them. So if I differentiate this, I will get dv d, good, dv dr. What does that differentiate to? Good, 2 pi r squared, and this will differentiate to ds dr, which is just 6 pi r. So looks like the important things that I've got here is this, and this. That doesn't look quite like an R, so let's just make that look a little bit better. Okay, what do we usually do with ds dt? Ahmed? What did you say? dv over dr times? If we do dv dr times ds dr, we don't get any of those rates of change cancelling out with each other, okay? So what we usually should do with these questions is we should start off with the thing that we have here. What do we normally do with the thing we start off with? Yeah, put it as the numerator, move the denominator so that you have dt. That's what we normally do. Now we're going to come across the issue that Sarah was hinting at. What do you notice? What letter are you tempted to put in here? Yeah, we would want to try and put dr in here. Let's do that in a different colour. That's great because I've got ds dr, but I don't have dr dt. Okay? So there's an issue here. I don't have what dr dt is. I could try and work out what dr dt is by doing some further calculations elsewhere. There is another way of being able to do this. But I prefer to do this in a slightly different way. What was your suggestion going to be, Amara?
Couldn't you just do like, you know, dv of dr?
Yeah.
You inverse it and then times it by dv over dt. Then you get dr over dt.
Absolutely. That is the way that you could find out what dr dt is. I'm just going to write down what Amara said. She said to find dr dt, you could do dr dv and times that by dv dt. Yeah, you could do that and then put that straight in there. I suppose the way that I normally like to think about this question, this is completely correct what Amara has said, is I like to instead recognize that if I can't do it with 2 connected rates of change, instead what I'm going to do is I'm going to do it with 3 rates of change, which is exactly what you've said. You're replacing that dr dt with 2 things, which means that we're going to have 3 things in total. I just think if I can't find one of them, why don't I try connecting 3 things together, which is exactly what you said, but it's just going to happen all at once. So the only thing I've got is ds dr, so that one's going to have to be a dr that I have there, so I'm going to fill that one with a dr, which means that one must be a dr as well. Then the only other thing I've got is v, so it looks like I'm going to have to put dv in here and dv in here, which is the same thing that Amara had suggested, apart from we're going to see that it's just going to happen as one single connected rates of change. So really this example is what I call a triple connected rates of change because we're connecting 3 things together here. So if you do ever get to that point where you're like, this doesn't seem, I don't feel like I've got the right variables, you can either do it with 3 or you can then actually find out what that other variable is that you needed. So putting all of these things together, we can now go straight in and say that ds by dr is 6 pi r. dr dv, we don't have dr dv, do we? Yeah, it's just going to be 1 over this because we've got dv over dr, so it's going to be multiplying it by 1 over 2 pi r squared, and dv dt is also something that we've got, which is just 6. Now, I personally would like to do lots of cancelling really quickly here. Luke, which things can you spot that can cancel? Yeah, so I could cancel this 2 with one of the 6's and replace it with a 3. Anything else? The pi will cancel with the pi here. The r will cancel with the squared part. So on the numerator, we've got 3 times 1 times 6, which is 18. And on the denominator, we've got r. So it simplifies really, really nicely. So that tells us that ds by dr is 18 over r. The only fact that we haven't used, though, is that they told us r was equal to 9. So when r is equal to 9, we have 18 over 9, which is 2. But what about units? What should the units be for this kind of thing? Sorry, it shouldn't say dr there, should it? I copied it out wrong. It's ds dt, so it should be centimetres squared per second that we've got. Okay, we've got some of those extra units of things. So there's really just knowing that you can connect multiple things together. In theory, you can connect 4 things together if you had that many variables. But I was impressed to see that, Amara, you suggested you already saw what dr dt was the same as. You actually already broke it down into those 2 things. The only difference is I've expressed that as one single line. It's absolutely identical, so that's fine then. So actually, I think the better thing for us to then do with this is there are some exam questions that will apply not necessarily this exact technique that we've got here, but it will now kind of pull together all of the different things that we've been doing in differential equations. There's not many questions from the homework exercise, exercise 9J, that felt very appropriate for this kind of topic. There's a few questions in there. If you're looking at doing any studying for this, there's a few questions in there that you probably won't be as good at doing. It's called setting up differential equations, because that will come up in integration, and it just doesn't make sense to kind of put it in differentiation. So if you do come across in exercise 9J a few questions and you're like, like I'm sure Mr. Bison hasn't told us how to do this bit, you definitely will know how to do that by the time that you've progressed in things with integration as well. So I'm going to pause that there.